do you guys belong to two batches or only the final year batch?
Final year batch, but there are two members from India.
Okay, so most of you have, I guess, already picked up the final year project, right? And worked, and worked on it for a little while, I guess. So the presentation is mainly around what are the good skills to be developed to conduct your final year presentation, so that you can really make something out of it rather than just completing it for the sake of completing it as a course module. And also what are the new technology areas that are important when you consider research when it comes to the commercial research, things like the research that we undertake in IT technology. So let's start the presentation. As the first thing, one good attitude that we would like the university students to grow is that to understand the importance of the university research projects, because with our experience with university final year projects and many other mini projects, what we see is some students think it like it just as a commitment to be made to just get through the course. But if you really look at the possibilities, really look at the potential in the final year project, there are a lot more that you can make. So these are the few opportunities that I have listed. You can, sorry about that. Your final year research project can be the best chance to practice the theories that you have learned in your courses, applying them into real problems as a test bed. You can test them under real world conditions, all the theories that you have learned during your courses. And also, there's a very good chance that you can undertake your final year project as an open source project. So if you have already started your final year projects, how many of you have started the open source project for your final year research work? Can you raise your hand? Very good. There are two of them. And I really encourage the rest of you to do that, because the research project can be the best entry point for you into the open source community. Because when you enter into the open source community, the pluses are that it's not like entering into a company. You don't have to go through interview process and there are no any formalities. You just can enter the community, and the recognition is strictly based on what you contribute to the community. So if you can make some significant appearance in the open source community, you will see that you get back a lot from the community as well. And at the time when you enter the industry, that experience will be immensely valuable. So starting the open source project for your research project is a very, very good idea. And experience a mini industrial project, because once you get into the industry, you become a paid worker. Right? There are not many opportunities to make mistakes, but you can make your final year project a mini version of a real commercial project, within which you can make mistakes, of course, because they will be excused. You will not be fired or something like that, or you will not be made fail. You can make mistakes, you can explore new avenues, you can explore new technologies and so on. So this final year project can be the best kind of pre-experience before you enter into the real industry. And of course, some of you, I guess, might be more interested in pursuing a career as an academic, right? Join the academic staff and do a PhD and so on. So if you are on that track, the final year project can help in that even, because I know many of my friends who made their academic career based on the final year project, their research project. Because once you embark upon a project, that becomes your research area, and research, as you know, it never ends. There's no horizon for it. You can continue it, and you can build a community upon it. You can make connections with other academic people who are interested in the same domain, and so on. So take it as a really valuable opportunity. The second thing, I think this slide might make sense, because this is one of the major flaws that we observe with the university students who do projects, who have done projects with us. Not all of them, but many of them, I would say. What they do is they take the project lightly in the beginning, because it looks like, okay, I have 6 months, so why should I go there right now? There are 6 months. 6 months is a lot of time, and let's stay until the final 3 weeks and do everything there. But once you reach these last 3 weeks, what you realize is that you don't have superpowers to conduct research during those 3 weeks. So the best idea is to start working on it as soon as you embark on your project, and have a time plan and run it as a commercial project. You might know this fact. One of the main differences between Europeans and us in the way that we work is that Asians mostly treat as time is something always available. The Asians think like time is something coming. Okay, I will have time. I have 2 more months, 3 more months. But Europeans think on the other way. They think time as something that is elapsing. Time is elapsing. So we have to do the work right now. So this is the right attitude that you should have towards your final year projects as well. So it's very important that right from the very beginning, create a good time plan and follow a standard industrial process like Agile. You can get help from companies like us. If you are not familiar with software development processes, there are few processes. Waterfall was one of the methods, but these days Agile methods are practiced by many people in the industry. So if you can follow Agile, that seems to be the best way. And also make your progress accountable. Keep somebody to report. In my idea, that should not be your academic supervisor, because academic supervisor is there to guide you through the academic, the technical, mostly through the technical part. But to report that, okay, I have done this thing this week, next week I hope to do this thing, have I achieved my milestones, and so on. For that, you have to keep somebody to whom you will be reporting. That will accelerate your work. Take my word, this will really accelerate. So what we do with the final year projects that we are undertaking is, in addition to the technical supervisor from our side, we assign another person, a manager from our side, who will be looking into the progress of the project. And if the student is not responding, or is not making satisfactory progression, then this person will become a nagging person, and he will call the students and maybe contact the lecturers and tell that, okay, this project is not going in the right direction, and so on. So it is very important to make your project accountable. So that is a formula for success. And use free tools to record time. You can find quite a number of tools, free tools for you to keep your time recorded. I did this thing today. I did this thing and spent this many hours on this task. And you will find this information immensely valuable at the end of the project to track down how did I progress. Okay. So having a time plan is very, very valuable. Sorry. Yeah. And this is regarding the final report. And another flow is that some students wait until the last moment to start writing the report, because at the end you have to submit the report for the project. So the best thing again is start writing the report right from the beginning of the project. So what you can do is, once you have formulated a time plan for the project, you will have several milestones. After 1 month I will achieve this target. After the next 6 weeks I will be at this stage and so on. And once you achieve these milestones, try to create a white paper, try to write an article on the content, on the work that you have done. So once you have the collection of those articles and white papers, you have several pluses. One thing is, you can keep an active project blog parallelly, active blog running parallel to your work. So one good idea is to create a separate blog for your final year project, or at least have your personal blog as the blog for your final year project, and write whatever you are finding, whatever the paths you explore, whatever the work you do under your final year project into this blog. So when the time comes at the end for you to write the final year report, the final report, it's only a matter of taking these notes that you have written and collecting them together. So the work will be lot less, and that will be thrilling as well, because if you wait until the end, what can happen is you might have forgotten what you have explored, what you have done, and write more reports at each milestone. And keep recording the references. That is important, because during the project time, once you refer to something, refer to a paper, refer to a book, a web page, anything, keep a separate document to record your references, so that at the end of the project you will have a very rich collection of references that you have referred, and you don't have to recall and memorize what you have referred to be included in the report. Okay. Then marketing your project, because when you take your final year project very, very seriously, and when you follow it according to a strict plan, then you have the confidence to go ahead and market your final year project. Okay guys, I am interested in this research domain. Now I am carrying out a project on NoSQL. These days I am working on my final year project, which is on cloud computing, and like that. So try marketing your project as much as possible. And the good news here is that with the social media tools available now, you have a very supportive infrastructure to do this. You can use Twitter, you can use even Facebook, and you can use your blog extensively to this. And believe me, and also you can use forums like the University Industry Bridge that we are also contributing. So the thing is this: when you actively contribute in these forums, these social media for a certain time, others also start noticing this. Okay, this guy seems to be a good guy in cloud computing. This guy seems to be a very skilled resource in mobile, and the industry will know about you once you pass out, and finding a job will be much easier if you do market your final year project correctly. Okay, so keep that in mind as well. Okay, when conducting a research, a very critical aspect is how you can be innovative, because as a research, you have to come up with something that is new, come up with something that did not exist prior. So for that, from my experience, what I can suggest is to have these good attitudes to be a good innovative thinker. As a first goal, you should dare to move out of your comfort zone. If you have already created a comfort zone, okay, I know C, I know C++, I will stay within that. My advice is that break those walls and make the move beyond that. Because as long as you are within your comfort zone, it will be very, very less likely that you will be an innovative thinker. You will be just doing the same thing again and again. And also, know that grandfather's stories too can help. That what I imply by that is, it's not only the technical knowledge that you gain through the 3-4 years during the university life that will help in your final year project. But if you really want to be innovative thinker, you will know that many other fields, your knowledge in many other fields, maybe even your knowledge that you gathered in school times can help in looking at a problem in a really different way and making a difference. The third point is put yourself under difficult conditions, because people make innovations when the conditions are difficult. If you look at world history, the greatest innovations are made at very, very difficult times, like the times of world wars. So, if you are not already under difficult condition, my advice is that at least simulate that you are under very difficult condition. So, in order to overcome the condition, you don't have any other option but to make innovation. And then what the fourth point says is that don't be strictly bound to a specific technology. Like, I am a Java guy, I am a HTML guy, and so on. It's very good to know certain technologies very well, but be open-minded for any technology, because when you are doing a research, you don't know what kind of technologies will best suit your requirement. So be open-minded about technologies. Yeah. And if you see theory on because from this slide onwards, the message I want to convey is how you can identify or how you can conceptualize research. Because before you start making a research, start doing a research, it is important to know the meaning of the word. It is important to have a systematic understanding of what research really means. What is the semantics of this? So I am not going to make an exhaustive kind of a exploration into the subject matter. What I will be doing is, I will explain our approach as 99x Technology. What is our approach when we undertake the university research projects? Our approach is the problem-solving approach. But when you say problem-solving approach, you should be you should clearly know that not every problem-solving falls under research. Let's take something like creating a website for a retail store. There's a retail store owner. He needs a website. That's his problem. And if you create a website for him, you solve his problem. That's problem solving. But that will be hardly a research, because there won't be much innovative stuff involved in that approach. So, in order to problem solving to be identified as a research, there should be a generalizable component to the solution. you have a problem, you innovatively work on a solution into that, and then you should be able to generalize that solution to an extent that that solution can be applied to solving similar other problems as well. So your solution should not be something that is only applicable to the problem that you worked on, but it should be generalizable. You should be able to generalize it so that other people in the future can use that knowledge to solve their problems as well. I have provided an example in the bottom part of the slide. The problem is how to go about storing data for structured log analysis. This is actually one of the research I am involved in. So I am involved in the research pertaining to structured log analysis. That is a very specific niche problem. And the problem is, what is the optimum way to store data in structured log analysis? And see the solution. The solution is to finding an effective way to handle huge heterogeneous trees. Because in structured log analysis, we identified that the data can be visualized as highly heterogeneous huge trees. Then our data storage strategy is finding an optimum way to effectively handle huge heterogeneous trees. So once we make our solution in line with that solution will be applicable to any problem that involves heterogeneous huge trees. So that will not be confined, that will not be limited to the very limited domain of structured log analysis. Even the problem was structured log analysis, but the solution we provide can be generalized into other domains as well. And so that is our basic approach into the research. Now, as examples, I will provide few examples of the types of research that you will encounter. One type of research is called inferential research. That is, there is a certain domain and you need to identify certain characteristics of the domain. But you don't have access to change that domain. What you can do is only analyze that domain. So what you do there is survey the population. You have a population, then you survey the population to determine its characteristics. The example, all these examples are from the research that we are carrying out in 99X Technology, either as in-house research or as university projects. So the problem is, what is the target phone model when developing a mobile application for developing countries? We want to start developing mobile applications for targeting developing countries. Now our problem is, what should be the phone model that we need to target? Is it a Nokia, very low-grade Nokia phone, or maybe some kind of a middle-grade Android phone? So that is the question. We need an answer for that before starting developing the mobile application. The solution is conduct a survey on user-preferred phone model during next 2 years in a developing country. So we prepare our questionnaire so that we get the answers from the users, so that they will be telling us what is the preferred mobile phone model for them in the next 2 years. So we can target the next 2 years and take the output from this research and see what should be our target mobile platform that we will be developing our software. So if you look at this problem, we don't have any control over the domain. We can't go there and change people's preferences on the mobile, their preferences on the mobile phones. What we are doing is just make a selection, a random selection on a population, and ask them certain questions and get the output. So we don't have any control over the variables. What we are doing is only a survey. So this is one type of research that you can do. A survey type of research which is called inferential. And the second type is this thing. Now in this kind of research, you have the ability to change variables in the domain, manipulate the environment to fabricate a solution. You have control over the environment, unlike the earlier case. Look at the example. What is the optimum way to extract log data? Log data means data from log file. So the optimum way means what is the best language, what is the best computer language that you can use to extract data from log file. So there you have a certain control. Now see the solution. Design a new data extraction language and fine tune it while comparing with the existing languages. So here you have the option to design your own data extraction language and then fine tune it, change it so that it can be made very much aligned with the requirements of the log data extraction. You have the control over the domain. So this is what we call the experimental type of research. And then there's another third type of research as well, which is called simulation type. So the description is construct an artificial environment as the test bed. In this type of research, we go even further than the experimental research. In experimental research, we have real log file which we can't change. What we can change is our solution. We can change the solution. We can change the solution, fine tune it, change the variables, change the environment, and see how it affects the problem, how it solves the problem. Now in the simulation kind of research, you can even manipulate the testing as well. That is, you can design your solution plus you can design a test environment to test your solution as well. When you see this example, it might become clearer. The problem is, what is the best 3D representation of a mind map for touch devices? For touch devices means smartphones, tablets. For those devices, what is the best 3D representation of a mind map? Now the solution. As the solution, we need to come up with a very effective 3D representation of a mind map for a touch device. But the problem is, it is very, very difficult for us to evaluate the feasibility of this model. Because let's say we come up with a very innovative 3D model. But in order to evaluate this model, what we need to do is, we have to install this in a touch device and then give these touch devices to people, and many people, and get their feedback. And also the feedback, it will be mostly subjective. This is not something that is very practical. So what we will do is, what we do as a testing for the solution is, we will simulate use actions on this 3D mind map model. Rather than giving it to the real human users, once we design the solution, we design a simulation simulating the user's actions, the touch and panning, scrolling and moving and things like that, adding nodes, deleting nodes and like that, and we simulate the environment to come to a conclusion on how effective our model is on addressing this problem. Okay, that is a simulation type of research. And then we have slightly different another type of research which people call longitudinal research. That is a research that you carry out in several phases because of the broadness of the problem. You can't just come up with a solution within like 6 months, like a 6-month single research. So what you do is, you take it phase by phase. You take a part of the problem, design a solution, bring it to the community, get their feedback, and move into the phase 2. And depending on the feedback for the phase 1, you design phase 2, and like that. You carry out it through a period, maybe spanning over years. So this kind of research might be very interesting for the people who hope to pursue a career in the academic. Because if at this point, if you start a longitudinal research, which will not end at this point, you can carry out that research throughout your academic career. That's what some people do, and actually I am also involved in one of those researches. That is what I have mentioned here as an example, how to develop a framework for structured log analysis. So structured log analysis is something that is not touched by many people at the moment. So that is an open problem, but as a problem, it's a huge domain. There are 100 problems that you have to address. So you can't address the whole problem domain within one research. What you do is break it into phases and do some research, make a IEEE publication, you present it in a IEEE conference. When you go to a conference and present this thing, you get feedback from people. Sometimes the feedback are really negative. People straightforwardly say that what you have done is useless or nothing, which is just a replication of something done by some other person. So you can pick all these responses from the people, and accordingly you can design your second phase of the research, and that is what you basically do during a longitudinal research, which is kind of a research that will last through several years. So all those 4 types that I have talked about earlier are called quantitative research. That is, you have a problem, you do a solution in a scientific way and then evaluate it in quantitative terms. Like for the original one I mentioned, when you conduct your survey, you can say that, okay, 55% of the users preferred Android and only 20% preferred Windows Mobile, and so on. So that is quantifiable, that is quantitative research. And one other entirely different area of research is to perform a qualitative research, where you can't actually quantize your results. This is one example. What is the impact of cross-cultural behavior in geographically distributed Scrum? Scrum is an agile process that is highly used in commercial projects. And for companies like us who do offshore development, who take offshore projects, we have to have distributed teams. We have one team in Colombo, one team in Norway, and another team in Denmark maybe, and have all those teams working collaboratively. And the research focuses on what are the impacts of the cultural differences between these teams working in from several countries. So that is something you can't really quantify, right? The cultural behaviors you can't really quantify. So as a solution, what you can formulate is analyze the literature and cases and to generate insights and impressions, some opinions. If you read the description, it is subjective assessment of attitudes, opinions and behavior. It's a subjective thing, but that is another really interesting area of research. If you like, you can pick one from that domain. Yeah. And so those are about some of the types of research that we are currently conducting. And these are some of the very hot technologies that are out there that you will see involving in many research, in current-based research. So in one area you get mobile applications. You have mobile optimized web applications, location-aware applications, the applications that make use of a user's geographical locations to provide certain kind of a functionality. And on the other side, you have on the server side, you have cloud and distributed highly efficient server models like Node.js, and if you want to create full platform independent UIs, you have HTML5, which is another hot emerging technology, and of course you have NoSQL as a very viable alternative to handling huge amounts of data compared to the currently existing relational databases. So those are some of the very hot technological areas. This is not an exhaustive list. There are few others as well. So when designing the solution to your research problem, it's better if you can make one of these hot new technologies involved as well, because then you have a better chance of entering into the industry. You will have a good knowledge on the current technological trends by the time you enter the industry.